So we move on to the next classification of polymers now, and next classification will be the classification on basis of intermolecular forces of attraction between polymeric chains. So this classification is based on classification on basis of intermolecular forces of attraction between polymeric chains. Now, this type of classification, a large number of polymer applications in different fields depend upon their unique mechanical properties like tensile strength, elasticity, toughness, etc. Now, these mechanical properties are governed by intermolecular forces that we'll be dealing with in this classification. So, intermolecular forces are playing an important part. Now, what are those? Van der Waals forces, hydrogen bonds present in the polymers. These forces also bind the polymer chains. Under this category, the polymers are classified into some subcategories, and let us now deal with these subcategories. So, we are dealing with classification on the basis of forces of attraction between the polymeric chains. The first category which arises, let us call it A, it is known as elastomers. They're called elastomers. Now, as the name suggests, they're indeed elastic in nature, and if a rough representation of them is done, they will look something like this. So, they're elastic in nature. So, let us have random distribution, randomly distributed, and they will have some linkages between them. So let us show some linkages, not many. So a rough representation can be this sort. Now on application of force, when we apply force on these elastomers, what happens is the length can extend up to 2 to 20 times of this particular elastomers. Okay. And when the force is removed, it comes back to its original state because it was initially coiled up and it had cross linkages which keeps them in place. So it has, when the force is removed that we were initially applying, the cross linkages are back in action and they coil up. They coil up the elastomers to its original position. But if a high force is applied, these cross linkages will break and therefore the elastomers cannot be oriented back to their initial position. Now they find a number of uses, these elastomers over here find a number of uses, particularly in the packing materials, the rubber bands that you commonly see. These are all elastomers. Okay. And they are amorphous, they have low density because they're not in close contact or not in close packing with each other, and they have low tensile property and they are elastic. That is very, very visible because the name itself suggests that they are elastomers. So a little something about elastomers, that we can say that elastomers are those polymers. So they are those polymers in which what happens is that weak intermolecular forces, so weak intermolecular forces can be seen. So forces of attraction, we'll write, are present between the polymeric chains. So since it is a classification based on intermolecular forces, so these have weak intermolecular forces of attraction present between polymeric chains. Polymeric chains. Okay. So the point to be noted here is that weak intermolecular forces of attraction between the polymeric chains. Now, some properties that we have to remember about them is, so firstly, polymeric chains are randomly oriented. So polymeric chains are randomly oriented. As I as we just saw in the rough diagram, so polymeric chains are randomly oriented. Okay. Next, a property that can be seen in these elastomers is that they are amorphous. Now, why are they amorphous? Because they are randomly oriented, and we have two forms, that is the crystalline and the amorphous form. And crystalline is for regular arrangement of particles. So, since they are not regularly arranged, therefore we can call them amorphous. The next property that can be seen is they can stretch on application of force. So, we can say that they can extend on application of force. Okay, and return back to original and return back to original. So we saw a property, and that is why they're called elastic, is because they can return back to their original state when the force is removed. When force is removed. Next, if we see another property that they possess, is that there are a few cross linkages between them, as we have already seen that these cross linkages are very important so that they can come back to the original state, and these are the ones that are contributing to that. So few cross linkages between polymeric chains. So another important property. Next, and the last one is that they are randomly coiled. So they are randomly coiled. So these is what elastomers are. So the main points were that they are randomly oriented, then they are amorphous, next extend on application of force, and they can extend up to 2 to 20 times of their original state, okay, and come back to its original state when the force is removed. There are only a few cross linkages present and very important to bring back to their original state, these cross linkages, okay, and they are randomly coiled. Now an example, a very good example that we have already seen of this is natural rubber. So natural rubber is an example of elastomers, and natural rubber we know is the polymer looks something like this. So we have CH2 followed closely by C and a CH3 attached over here with a double bond because of 1,4 addition and CH2, that too these will be N units. So this is natural rubber, and natural rubber over here is a very good example of elastomers. Now, what we do next is that when we take this natural rubber, we want to improve the properties of this natural rubber. Some of the properties we want which are not according to our liking. So what we do is we take this natural rubber. So run we're drawing it in this simple manner, so but they're randomly oriented, please remember. So what we do is we put sulfur. How are we putting the sulfur? So what we're doing is, see, there were initially some cross linkages like this, and we will be breaking a few cross linkages, and in place of it we are placing sulfur. Okay, so we are placing sulfur, and this particular process is known as the vulcanization of rubber. So this is known as vulcanization of rubber. Okay, vulcanization of rubber. Now, why are we doing this? In order to improve the properties of natural rubber, we treat it with sulfur. It develops cross linkages between the polymeric chain, that is the sulfur. We have developing polymeric chain between these two polymeric chains, cross linkages between the polymeric chains of sulfur, and this improves the property of natural rubber. So these sulfur cross linkages are actually the extra cross linkages between rubber that we had previously seen. So vulcanization of rubber is done in order to improve the natural, or you can say in order to improve the properties of natural rubber. What we do is it is treated with, or it is treated in presence of what? Sulfur. Okay, and this process is known as vulcanization. So what happens is it develops cross linkages. Okay, so cross linkages between the polymeric chain. This sulfur does this between the polymeric chains. So this leads to our natural rubber showing better properties than its than it was originally showing, and therefore it is to our liking. So this particular process is the vulcanization of rubber or natural rubber.